Welcome to qnawire.
Okay, we have 69.0 grams of sodium, and we need to know the number of atoms in 69 grams of sodium. So if we knew the number of atoms per gram, we'd be good. Okay, well, we don't know the number of atoms per gram, but we do know that Avogadro's number tells us there are 6.02214 times 10 to the 23rd atoms per mole. And we were told that there are 22.99 grams per mole of sodium, right? So we can get atoms out of this. We just need to take 69.0 grams, right? And then we want to get rid of grams, so we want to do 1 mole for every 22.9 grams, 9 grams. And then the grams will then cancel, and we don't want to know moles, we want to know atoms, so we do 6.02214 times 10 to the 23rd atoms per mole, so the moles will cancel, and we get the final answer of, I've got to put this in my calculator, 69.0 divided by 22.9 times Avogadro's number, and I get out 1.807. We need 4 sig figs times 10 to the 24 atoms. Right. So let's move on to the next one. Calculate the mass in grams of 472 iron atoms. Okay. So we know atoms, but we want to know grams. Once again, we could figure this out. We're going to use Avogadro's number to give us the number of moles we have, and then we know grams per mole. So we would multiply this by moles per atom so that the atoms cancel, and then grams per mole so that the moles cancel, right? So I see 472 atoms. Then moles per atom, it's 1 mole has Avogadro's number of atoms. That's Na is the 6.02214 times 10 to the 23rd. Okay, and then grams per mole, they told us, is 55.85 grams per mole. Does everything cancel? Atoms cancels with atoms, moles cancels with moles, and we get grams as our final answer. And I see 472 divided by Avogadro's number times 55.85. I get 4.37. Let's see, we got 3 sig figs here. 4.37 actually rounds to 4.38 times 10 to the negative 20 grams. Okay, number of molecules in 10.7 grams CO2. Okay, so now we've got grams, but we want molecules. Now, Avogadro's number will be handy again because that would tell us, if we can figure out how many moles we have, that would tell us how many molecules we have, right? So if we can get to moles from grams, we'll be good. So what if we go moles per gram and then molecules per mole? That seems like a good idea, right? Grams would cancel, moles would cancel, and we get our final answer in molecules. Okay, so let's do that. 10.7 grams CO2 times, how do we relate moles to grams? That would be the molecular weight of CO2, which they did not tell us, which is inconvenient, so I have to look that up. Molecular weight of CO2 is 44.01. 1 mole has 44.01 grams. Okay, and then we don't want moles, we want molecules. So we know that there are I'll just say Avogadro's number of molecules per mole. Okay, so then I start calculating this and I get 10.7 divided by 44.01 times Avogadro's number, and we get 1.464. Actually, we only want 3 sig figs, so 1.46 times 10 to the 23rd molecules. All right, last one. How many grams are in I2? I think that's iodine gas. Okay, so we've got 3.91 times 10 to the 25th I2 molecules. Okay, but we want grams, right? So we need to get rid of molecules first by converting to moles. Moles per molecule. And then we'll use grams per mole. Grams per mole to get rid of moles, and we'll be left with grams. Okay, so 3.91 times 10 to the 25th times, moles per molecule, that's Avogadro's number. That's 1 mole for Avogadro's number with the molecules. And then grams per mole, they didn't tell us. It's I2, but we can get it from the periodic table or Google it. Weight of I2. The iodine by itself is 126.90. Let's see. 253.81 grams per mole. And what's this going to equal? I see 3.91 to the 25th divided by Avogadro's number and times 253.81 for a final answer of 16,479 grams, which if we want to keep sig figs, we would have to write in scientific notation. So we'd have to do 1.64 times 10 to the 1, 2, 3, 4. There we are.